Good morning, good afternoon, good evening to you all, depending on where you're tuning in from. Thank you very much for joining our DevTalk today, the first DevTalk of 2023, in fact. So just before we get into the presentation itself, there's a few sort of housekeeping rules and some things that we just want to touch on. So firstly, I wanted to just encourage you all to join our developer community. Specifically our developer portal, where you can access a ton of information about all of our developer tools and products. You can view our developer related content. You can also engage with our community through our forums there as well. If you weren't aware, we've just recently redesigned our developer portal. We released that towards the end of January of this year. So it's a completely fresh new experience. And we've also revamped all of the content on the site as well. So really do encourage you to check out those resources. And of course, if you have any feedback for us, we're all ears. With that said, we also have our LinkedIn, our Twitter, and our GitHub pages there as well for you to check out. So yeah, next slide, please, Nicola. Thank you.
Sorry, yeah, it goes.
So no problem. So just before we get into this event itself, I just wanted to make you aware of some other events that we have coming up. So our next DevTalk will be in March, and this will be from the Zebra Aurora Vision team. So they'll be providing you an update on their latest release. We'll have a little bit more specific detail on that in due course, but one to keep an eye out. We'll also be sponsoring DroidCon this year. I can happily confirm that. And we'll be in Berlin and London. So if you're in those regions, please do come along and say hello to us. We'll have a booth there and we'll also be doing a talk. But most importantly, I would like to make you aware of DevCon, which will be taking place in September in Madrid. So from the 13th to the 15th of September. This will be an in-person Zebra developer conference. There'll be a ton of really good information here, not just from our mobile computing business unit, but for our other product sets as well. So we really do encourage you to sort of earmark those dates and come along if you can. So enough from me. I'm going to hand straight over to Nicola, one of our SME software engineers here at Zebra, and he's going to walk you through how you can develop Maui applications using our existing Xamarin SDK. So that's enough from me. Over to you. Thanks.
Fantastic, James. Thank you so much, and good day, everyone. And so, thanks for joining this DevTalk on .NET Maui. And so, let's give it a start. First of all, what's happening out there with regards to Xamarin, Maui, and the Zebra EMDK library? Well, for sure, Xamarin is being sunset. And this link from the Microsoft documentation is stating that the last date the Xamarin support will go through is May 1st next year. That means that sooner or later you have to evaluate to move to the next platform. By the way, here I embedded the links that you see during the presentation in a QR code, so you can also frame them with your camera and access them in lively. Second thing, the Zebra EMDK support for Xamarin has been offered for a long time. And of course, our customers and the ISVs are concerned about the SDK's future, of course, being strictly linked to the Xamarin future. Fortunately, there's a good news. A new framework is replacing Xamarin, and it's .NET Maui. This DevTalk will walk you through the steps to migrate your current application or to write a brand new application in the Maui development environment using our current EMDK library. Before diving in, let's have a look at the agenda. So a quick introduction to Maui. Just a few words if you don't yet know the development environment framework. Then we'll see how it compares to Xamarin. And we'll see how to set up the development environment just before start understanding how to write your first application, both with the Xamarin Maui and the Blazor Maui, because Maui has an option to write the user interface in a couple of ways, and we'll see how and the details. Then we move on with a couple of tips regarding the Visual Studio and the developer environment, a couple of points on the roadmap, and the final recap, and then the question time. By the way, my name is Nicola De Zolt. As James said, I'm a Zebra software engineer focusing on the developer experience on the Zebra mobile computers. We can see more in details what is Maui and why you should care about it. So if you really want to have a full insight of Maui, the Microsoft documentation is the right place to go. Here you, of course, can find everything from the Getting Started guides, the tutorials, the fundamentals, and so on, till the most advanced topics. But of course, we need to have a quick understanding of this developer environment, and so I put a couple of points here for you. Maui means .NET Multi-Platform App UI, and so it is a cross-platform framework for creating native mobile and desktop application with the programming language C#, and as I said before, with the choice of XAML or Blazor as the user interface programming language, markup language. Maui is can develop application with this environment that run on Android, iOS, macOS, Windows, starting from a single shared code, and this is the key success factor for this framework. .NET Maui is an open source project and is the evolution of Xamarin Forms. That's why we are evaluating today how to port our projects and use the EMDK from Xamarin to Maui. The question about how Zebra will be moving and when to support officially the EMDK. We are actively working on this, and I can share that soon you get some communication. Stay tuned on our developer portal, our social outlets. And the good news is that although it's not officially supported, you can already use the current EMDK library to build the Maui application. Let's see how in a moment. Before going in depth in the code, let's start comparing the two architectures. The left side of this picture is taken from the official Microsoft documentation. The central one about Xamarin has been drawn by me, and just to have a one-to-one comparison of all the building blocks of this architecture. They are pretty similar. The main differences can be seen in the lower part, where you see that Maui is targeting 4 platforms: Android, iOS, macOS, and Windows, compared to the 3 addressed by Xamarin. But let's start from the top. Your code, the code that you write, will stay on the .NET Maui framework, and that's why we say that .NET Maui compares to Xamarin Forms. This is the first fact, and the second is that the .NET for Android branch of Maui compares to the Xamarin Android. This is important because our EMDK for Xamarin library has been built to deal with the Xamarin Android, and so the talk today is about using this library that I marked this block with the label EMDK for Xamarin inside the .NET for Android. An additional comparison is about how you write applications for Maui. You have 2 options basically. Follow the numbers here on the left side of the picture. The first way is to write a full .NET Maui application, which means an application that is targeting most, if not all, the platform. In that case, you follow the number 1 and 3. That means that your app code deals and leverages the .NET Maui APIs, and then it's the framework that targets the single platforms. You have, and to do that, just what I said, you're choosing the Net Maui app template in Visual Studio when you create a new application for that. But you have also another option to write your application code directly for .NET for Android, so limiting it to the Android or another platform as a target. In that case, you choose the Android application to build a simpler project just for Android. That said, let's see how to set up the developer environment, which is of course based on Microsoft Visual Studio. It's up to you to use the community edition or the professional one. You see here the version I've used, but for instance, today I've got the notification that the new 17.5 version is available. So check the latest one when you start working with this. Installing Visual Studio means downloading the Visual Studio installer as a first thing, and so inside that application, be sure to check the .NET multi-platform app UI development, the one I'm showing here in this snippet, because it's this type of installation that creates and installs all the files and SDKs to work with .NET Maui. Once done, this is pretty standard actions. You have to integrate the tools provided by Zebra, and there are a couple of tools for that. Let me check here. I'll make it a little smaller here just to give you a glimpse of site. If you click this, by the way, there's a handout PDF file available for you in the GoToWebinar application, and you'll find all the links I'm clicking here in the presentation. In this page, which is the AMDK for Xamarin landing page in the techtalks.zebra.com, you see the latest recommendation for setting up the developer environment. And the first action is to install the Visual Studio extension with the version 8.0.08. I'd like to show you live, though I have reported this in the slides. To do this, just choose the extension menu and ignore the fact that EMDK is already installed in my Visual Studio. You are brought to the Manage Extension window, and on the Online menu, just type EMDK. Doing that brings up the EMDK for Xamarin. If this is not installed, from here you can start installing. Once done, the installation is along the other listed in the installed version, and you are able to uninstall eventually. The extension is necessary for the EMDK profile to work, and if you run this, you have the confirmation of the version that you have installed. And to your curiosity, the profile manager is something that resembles like this. From here, you start creating the profiles and saving them into an asset folder of your Android project. This is not the focus of the presentation today, but is necessary for the development environment to work smoothly with the EMDK installed. Let's move on. We can start looking at the code, and I'd like to show the first code with the XAML syntax. And since I'm not a fan of the code snippets embedded in the presentation, I prefer to arrange a couple of projects. These are available on our corporate GitHub, the repository, which is called Zebra Devs. If I click here, just to give you an example of how this is looking, This has just been posted a few days ago, and you have all the project available. Should work and compile out of the box if you try it. The two projects are pretty similar. They use the profile manager, but in the first one, I'm also using other features from the EMDK, namely the version manager and also the notification manager, just to test them and make you aware that they are also available on top of the profile manager. In the EMDK Maui demo app, I'm also using the community toolkit MVVN, not just to refurbish the code structure, but because it's offering a way to communicate across the application layers, and we'll see how. The profiles clock sample instead is altering the system date and time of your Android device in real time, so it's even easier to see when it's working and how. If you frame this barcode, you can immediately access the code, as I told you before. The first thing that you need to learn when you want to integrate our EMDK in your projects is to add the EMDK dependencies. For your information, the EMDK for Xamarin is published on the NuGet public repository. The NuGet has this page. The latest version is 8002. Please note that this is different than the extension installed before. And you don't really need to care about the repository in itself, because you might be aware there is a simple way to install the dependency, and this is called the NuGet Package Manager, accessible from the Tools menu in Visual Studio. You choose a Manage NuGet Package for Solutions, and once again, if the EMDK is not installed and it's the first time you're looking for that, you just type EMDK. This is popping up along with other stuff. And since in my case, this is been already installed, if you click the project, it offers the way to uninstall it. But if it's not present in the solution, you start the procedure to install it, which generally includes license confirmation, and other stuff that you have to confirm. Once done, the symbol.xamarin EMDK gets installed and is available for use. If you want to be sure that this is successfully installed in the right way, the place to look at is the dependency folder of your project. Expand the net Android folder, because the library, of course, gets installed only in the Android branch. You must see it listed in the packages, and if you want to know the DLL name, it's here. It's a symbol Xamarin EMDK.dll. We'll see later that if you even want to check if this has been successfully installed, you can right-click the package and open the folder in File Explorer. And once done, you're brought here. And the DLL is inside the lib mono Android, and here is the DLL. This file must be in place for everything to work smoothly in your project. Once done, we can move on. This is what I've already shown you a moment ago, so we can even move to the next slide and start looking at the code. And before the code, let's try understanding how a Maui project is done. You can see that there are several folders and files, but you have just to focus on a bunch of them. Everything starts with the main page remember that this is a XAML project, and so the UI is described in terms of a XAML language, which resembles an HTML, but is proprietary from Microsoft. Exactly. And the UI components are like these. For instance, a label, an image, and a button, and so on. This file is paired with another one which holds the same name but ends with the CS extension and holds the code behind, the so-called code behind. Because from this file, you can access directly the components of the UI described in terms of XAML components. So, for instance, if your code wants to write some text in this label, you just have to X-name the label with a specific identifier, like LB welcome, for instance, and you don't need to do any initialization, nothing else. That component is available for your code in this file, and you can simply use it. For instance, you want to assign a new text string to it, you access the text property and you assign it with the equal sign. Pretty simple. That's the part of the code which is common to all the platform if you are building for and targeting multiple platforms. We are, of course, are interested in the Android platform, and so expand the platform folder. Before diving into the Android one, please note the different targets that are available. You don't have to enable them all together. In the project property, you can decide to enable 1, 2, or whatever is your preference. And inside the Android, you find a folder structure that resembles the one typically used through the Android Studio, though missing of some elements that are common to all the platform. For sure, you'll find the main activity CS, which is the entry point of the Android application. We'll come back here in a moment. And also the Android manifest. The Android manifest in particular, this is an important point, is created with some features already present, but you need to tweak it a bit and add the specification for the EMDK in order to be able to use it. If you don't do that, of course, the library is inaccessible. And the two things you need to do, maybe three, are adding inside the application tag the uses library, like this one. Then you have to specify the uses permission of the permission EMDK, and also for in the latest version, the query packages in order to be able to access it. That said, we can, okay, and there's still another file that was mentioning, and it's the asset folder and its content. Here, the profile manager, the one that I've installed in the extension that I've shown you before, is saving the EMDK config XML, which holds the profiles created through the profile manager, or copy and paste there in order to be applied for specific configurations. That said, I think we can move on just to have a closer look at the main application here and understand a bit, if you've never seen this before, how to use the EMDK and understanding its life cycle. The first thing you need to do is declaring the implementation of two interfaces. These two interfaces are offering and need to implement them, of course. You have to manage the creation and the release of the EMDK manager. And since the entry point of the application is on create, but we prefer to create the first insert of the EMDK manager in the onPost create method. And here, this is your first call to the EMDK. It's an asynchronous call, of course. So the results that you get is not the EMDK manager. It's just the success or the failure of these actions. Once the EMDK manager is available to your application, the open callback is triggered, and starting here, you can invoke one of the features of the EMDK manager. As I said before, for this example, I used the profile manager, the version, the notification. Once again, the creation of these objects is asynchronous, which means that you invoke this, but you expect, in this case, that callback is called 3 times, one for each of the manager that I mentioned before. This is happening in the onStatus callback, and through some branching in your code, you start using, for instance, the profile manager, or the version manager, or the notification, or whatever you decided to use and implement. The version manager, for instance, is pretty simple, and the elaboration ends here. So once you have an instance of the version manager, you can simply invoke the EMDK version or get the MX version, put the results in a string, and for later retrieval and printing on the screen. The profile manager is a bit more complex, because when you want to process a profile, you can do that again in an asynchronous way. You specify the name of the profile, and I'll remind you that, for instance, in this XML, the profile name is some settings, and I put it here. So you call it by name, use the flags that are documented for this method to be called, and in the end, the result is triggered in a profile manager underscore data callback, where you can understand if with the checkml error function, if the profile was successfully applied or not, the reason for that, and so on. On top of all the action you want to perform at the end of these actions, here I decided to write to send the files and the results to the cursor, and that's way you are able to see the results in the printed on the screen. For that, I use the weak reference message. That is something that I mentioned before. Is based on the Microsoft Toolkit MVVN. This is I guess this is like a bus that is across all the application components. And the fact that it's called a weak reference is because of the fact that you don't need to take care of the life cycle of this object, and so you can create and use it anytime you want, and it's a garbage collector that takes charge of creating and destroying the object. That said, let me come back for a moment to the slides. I just want to show you how to show the results on the main page, because this weak reference messenger must be registered where you want to show the results, and so I did it in the constructor of the main page. This means that every time that process profile completes its actions, I'm receiving a message here in the M variable, and I'm able to print this to the lb welcome.txt text and see it as part of the label on the screen. You can see all the code, as I said, here, so it's worth going deeper with the code description. We have also got some questions and interest about Maui Blazor, which means the different way that the user interface is rendered on a Maui project. And yes, the Xamarin EMDK can also be used successfully in a Maui project based on Blazor. And since not everybody can be can know what Blazor is, here a quick introduction to this technology. The Maui Blazor is part of the so-called Blazor hybrid applications, using Blazor in a native client application. Blazor in itself is a framework for building interactive UI application based on web, and Razor is a component of the page. And pure Blazor applications are rendered in desktop or mobile browsers. We instead want to render a web interface in a hybrid and in a native application. So the first thing is to embed a web view inside your application and write the user interface in terms of HTML language. There's no HTTP communication involved in that. There's a local interoperational channel to move the information between the core of the application to the user interface. Blazor Hybrid is available for several platforms, and .NET Maui is one of these. So .NET Maui is capable of using Blazor in place of the XAML for building the user interface. And the reason why you want to use the Blazor Hybrid approach is probably because you have already available a web application, a pure web application written in Blazor, and so it's of course convenient to move this application to a native mobile application, or you want to simply leverage all your skills of native and web application development, so you have the chance to leverage and put at work both. Here I collected a couple of references about Maui Blazor from the definitions, the markup language, and its syntax, till building a .NET Maui Blazor application from the Microsoft Learn page, which is what I did in order to firstly build the application as a standard sample Maui Blazor application, and then integrating the EMDK. Let's see how this worked. Let me make this a little bigger and bring up the code for this application. First of all, if you want to use and write an application from scratch in .NET Maui Blazor, you have a specific template to use. If not available in your Visual Studio, just type it in and it will be downloaded and it will be ready to use. The project structure is a little bit more complex than the XAML version, because you have a sort of server inside that manages all the pages described in terms of Razor components. Instead, the part of native development, so the target platform like Android, iOS, and so on, are more or less the same as the XAML. So I can tell you that, for instance, for the Android code, I just copy-paste most of the code from the XAML project. A curiosity here, but we can have a look directly on Visual Studio. The project itself is always a XAML project, so the main page is described in terms of XAML, but the unique component inside the XAML is a Blazor web view, and that's it. Everything else is delegated to the Blazor web view and its UI. And the first things of course that you have to specify is a host page, so the landing page of your application, which is one of the files inside your application. Let's see it for a moment how this is showing. And if you remember before, when I show you the XAML project, the main page had a long list of components that are building the user interface. Here instead, we have just the Blazor view, and that's it. And the same is happening here. Nothing can be done at this level. Everything is delegated to some components, and for the sake of understanding how this works, I use the fetch razor here, page, in order to print the result of detecting the EMDK version in the same way I did before for the XAML project. So in order, I created as before all the code that I've just shown you for the other project in the Android branch, implementing the listener and so on. Let's go down. I just used the feature type version, and when this is ready, I'm collecting the EMDK version and the MX version, and I'm sending, as I did before, through the weak reference messenger, this the text string to the user interface. In order to do that, I just tweaked a bit the weather forecast service that is one of the classes included in this project as a sample code. I added a constructor of this class where I registered the listener for the messenger, and here is where I'm receiving the string from the Android branch. Once this is received and saved locally, when the application is calling this service with a specific asynchronous call, the message is returned along with other information that is already present in this application. And everything is happening in, and so this is the foremost page of the application. This is how a Razor page looks like. You have a part of the code which is XML, which is an HTML syntax embedded with comments that are in variables managed by the code, which is in the lower part of this page. And in this case, the forecast service calls the method that I've shown before, the get forecast async, and the array. Once this is ready, all the values are rendered in a page as rows of a table, plus the string of the message that I've added to show that the application is getting the result from the EMDK calls. This is depicted in this slide, and this is exactly what I've just told you, and that is happening. And here is how the Maui Blazor page is looking with the results from the EMDK. For instance, the latest Android 13 devices are supporting an EMDK version number 13 and the MX 11.8. Once again, the project is published on our Zebra Devs, so it's available for you for immediate download and modifications. The code, and I think I've covered everything I wanted to show you about the EMDK integration. Just a couple of tips for you about the integration of our SDK. Sometimes it happens that you have installed the EMDK, but the IntelliSense complains that the EMDK manager couldn't be found. When it happens, probably there's something wrong in the installation. First thing you should try is to simply uninstall and reinstall through the NuGet package manager. But if this is not working, the suggestion is double-click on the project name, bring up the configuration files, and go down till you see the item group, which is included in the Xamarin EMDK, and try. You can delete it safely. Don't break, of course, the remaining items of this file, and you can try download it from here once again. If this is not yet enough, as I said before, you can always right-click the package, open it in the package manager, go up one folder, and you can completely remove this folder in order to be to reinstall it from scratch. And as I said before, always check if the symbol Xamarin EMDK DLL is in place. Tip number 2, if you're working with Android Enterprise, you might have to deal with the cope mode. The cope mode is the old-fashioned name for the fully managed device with a work profile, but it's easy, of course, to say cope mode, so I'll call this. Basically, it's the way of enrolling a device with a profile owner. So you have two profiles, the personal one, which usually holds a user ID number 0, and the work profile, which usually holds the user ID number 10. When you have two profiles like this and you start your Visual Studio debugger, the application is installed in both profiles. So for the work profile, you get your badged application in the way I'm showing in the bottom left side of this image. But if you start the debugging, the debugger relates to the personal version of the application. So it's about the user number 0. If you want to debug the application installed as work profile, you need to include in the project file the launch flag -- user number 10 or whatever number that work profile holds, because this is exactly the same switch used by ADB to attach and work in the work context. Another recommendation, if you want to distribute for debugging purposes the APK from the debug version, be mindful to deactivate the fast deployment flag, which is by default enabled, in order to get a fully qualified APK that installed successfully and runs successfully on all devices. In the right side here, I'm showing a snippet of the screen for the sample application running as user number 10 and successfully debugging that that version. It's important to debug, of course, the profile version of your application, because you, for instance, have a completely different paths available on the file system for the user number 10, and so it's a good validation of your application. Tip number 3. Tip number 3 is about debugging again. pretty simple thing, but annoying one. Sometimes you have your Zebra device connected to the USB with all the ADB permissions and flags enabled. Despite that, you're not able to debug it. That's a very simple way to solve this. From inside the Visual Studio, under the Tools menu, Android do a restart ADB server, and usually this fixes this issue, and your Zebra Technologies device will show up and will be ready for debugging. Final slides, the roadmap one, as I said before, the EMDK support for Maui has been prioritized. The work is underway, and the actual release date will be communicated soon. Be mindful that we are also making changes to the EMDK that are targeted to Android 14. So for the moment, for Android 13, nothing changes from your perspective. But if you are a StageNav user, for instance, you might have seen some changes about the type of profile barcodes for configurations that are offered in the latest version. So there's something going on this regard. For both these things that I've just mentioned, more information will be coming over the next couple of months, so stay tuned again on our social outlets and the official websites for final communications. Conclusions. After these 45 minutes or so, you should be able to manage a simple Maui project, understanding the two options of the XAML and Blazor user interfaces, managing the EMDK lifecycle, and more specifically, integrating the symbol EMDK for Xamarin into your code. Some of the information that are covered today are also gathered in my blog, which is available at the address that you see here. So on top of the handout that is available with the links of this presentation, you can also just have a look at the blog. With this, I think I've covered everything. I thank you so much for your attention, and I wish you happy coding. The line is back to James.
Thank you very much, Nicola. Very insightful talk and very much appreciated. So we're slightly over time, so we'll try and get through these questions relatively quickly, but we only have a handful so far. As Nicola's mentioned, we do have a handout available with all of the links from the presentation, so please do check that out, and the presentation will also be published to YouTube on our DevTalk playlist just about a week from now. So to jump straight into the questions, a question from Lucas, just excuse me. What do we need those profiles which can be created in Visual Studio for?
So the question is about what's the reason for using profiles? It's pretty simple. With EMDK, you have access to the so-called MX features, which are a set of API exposed on top of the standard Android APIs, and are typically used to have a programmatic configuration of Android features, which are usually not available to a programmer, but just through manual UI settings, or are not available at all. This is because in our environment, in the enterprise, we usually don't want that a user is accessing a settings menu to set up, for instance, wireless Bluetooth behaviors or so on. We want to do that programmatically, and the EMDK profiles are done for that, are there for that. You can find in our Tech Docs website all the answers and the specification about each profile available. In the example that I brought up so far, for instance, in my one, if I can show this one, this profile is the so-called display manager, and in this case I was changing programmatically through the profile the timeout interval of the display, so after how many seconds the display switches off, which is something that, as I said, you can usually do programmatically. You can change several of these into one profile, of course, and apply at the beginning of your application or at runtime in any moment you prefer. That's the reason why they are there.
Okay, thank you. Question here from Tim. What API level is required on the device in order to use Maui and the EMDK?
Oh, this is listed in the Tech Docs. I can't frankly remember them, but we can see if you access the page that I've shown before, the landing page for the EMDK Xamarin, you have all the answer here somehow, because depending on the MX level, you have to target the specific frameworks and the specific target API, which of course have to be paired with the API of the Android installation. So, for instance, Android 11 or Android 13 require a specific API to run. So, I don't have further details on this.
No problem. Yep. So it sounds like the information is just buried within Tech Docs, Tim.
Definitely.
Okay. Yeah. So question here from Vim. This is quite a broad question. So how would I go about creating a .NET Maui APK that runs on a Zebra device and also on a consumer mobile device? I think the question is, how would you create one app that uses scanning, the EMDK or data edge for scanning on Zebra devices, and then also uses a third-party library for consumer devices?
Mm-hmm. This is a switch that you usually manage at code level, detecting the presence of the EMDK. And in that case, if you want to deal with the EMDK, you can, for instance, apply the profiles as I did. This is documented, but I'm not able to find the link right now. We can follow up with this. There's a way to understand if the EMDK is available, and so understanding if you're running on a Zebra device or not. If your question is about just using the barcode scanning, we are offering intent API for that, and so it's even easier to manage the difference between a Zebra device and a non-Zebra device in that case. Hope that answered.
Thanks, Nicola. Yeah. So a couple of questions here from a handful of people regarding Maui support for some of our other SDKs, things like our RFID readers and our printer SDK. So I'm going to go out on a limb here and say that this isn't really Nicola's area of expertise. He focuses on the mobile computers. I personally will take these questions to the business unit, but I would also recommend that if this is something you're looking for, to post on our developer portal forums or comment on a post that's already there. Any interactions we get through that will help us build the case internally to get that support if it's not already planned. So please visit our forums and sort of raise the alarm there, and I will also take it back to the relevant teams. So Fabrice has a question around Android emulators. Can you explain which Android emulator you are using?
No Android emulator. We don't have Android emulator. Everything you have seen is done through a real Zebra device, the one that I've used here in this picture. So it's hard connected through the USB, and we don't offer emulators for that.
Okay, perfect. So a question here from Matthew. So what about an EMDK extension for Visual Studio for Mac? Do you know if that is in the pipeline?
Oh, good question. I didn't try it. Can you repeat the question, James?
Yeah,
Sorry.
so the EMDK extension for Visual Studio, a Mac version of that, I think Matthew's looking for.
Not sure exactly if this can be run there. I don't frankly know, if I've never used that for.
Maybe we can take that back to the product team.
Yes, exactly. Absolutely. No, here I can't see anything, so no, we have to get back later on this.
Okay, all right, thank you very much. So yeah, just having a look through the questions, a lot of them are focused on RFID and printing as well.
Sorry,
so
that's another.
Yeah, so we'll definitely take those comments back to the product team. It seems like a lot of you are interested in that. So which Zebra handheld devices will not support .NET Maui? Are there any devices that won't support it?
Not that I'm aware of, frankly. This is Maui, as I said, builds a native application, so you get an APK out of that. And if you're targeting the right API and for the device you have in your hands, I don't see any issues on using that. It's not linked to the specific device.
I would agree. Okay. Is there a NuGet package instead of a Visual Studio extension for the
EMDK? If the question is for the EMDK profile manager, no. The NuGet package is for the library, and for the extension is managed separately in this way. This was our engineering choice. I don't know why they choose to build that way.
Understood. So this is our last question here. So if you do have a question, we've got a minute or two, you could get that into us. But as it stands, this is our last question. Is there anything noticeable in regards to a .NET Maui app and a Zebra device enrolled in Microsoft Intune?
Yeah. Not that I'm aware specifically. You have seen my tip number 2 about debugging in code mode. This is here because we usually work with devices under some EMM. I don't have a specific experience on Intune, but as I said, the most complex case is when you have two profiles. So from the developer's perspective, you have to manage 2 different profiles and different contexts, for instance, for the file system and everything. And here I explained how to debug the 2 applications. If you have just a fully managed device, you go back to the one single profile and the user ID number 0, like a person 1, and your application, if it's not violating some restriction that the EMM might be imposing, there are no direct relationship between the 2.
Thank you. So this one isn't a question, but Bim has taken it upon himself to take a look through tech docs for us and have a look at the Maui support. Oh, in fact, the .NET documentation, I should say. So .NET Maui supports Android 5.0 and higher. So as long as you're running a device 5.0 and higher, which you probably are, .NET Maui will support it. So a question from Fabrice. Profile Manager is not running. I got a Java error. Do you have an idea of what happened? So I'm going to go out on a limb here and say that if Profile Manager wasn't running, perhaps it was too soon after a device boot. I know there's a little bit of a delay between the boot and that being available. Nicola, do you have any thoughts on what that might be?
It depends if they mean the profile manager, the feature type of EMDK, or the extension profile manager wizard, I mean.
Yeah, maybe in this instance, Fabrice, it seems like a specific error. I'd recommend you reach out on our developer portal forums, and we'll have someone respond to you there. So there was it was the extension profile manager. Fabrice just clarified.
Extension profile manager means the wizard to build the profiles. If it's failing, check that you're running Visual Studio 2022 for sure, and that it's updated like the 17.4 or 5 for sure. If not working, try reinstalling or ask to open a case on this. It's impossible to troubleshoot from now at the moment, I'd say.
Okay, no problem. So that actually brings us to an end. We're just a minute over there. So if you do have any remaining questions, again, you can contact us developer@zebra.com by email, or you can contact us directly through our developer portal forums as well. So thank you all very much for your time and attendance today. We hope you enjoyed this session. Thank you very much, especially to Nicola for the great presentation. And we'll see you again in a couple of weeks' time for March's DevTalk. So thanks, everyone.
Thank you all for me. Bye.